So the first slide, this is a nice sort of broad picture of, I don't know if you will recognize it. It's right there on the east coast of Trinidad at called CIB. And this is one of Professor Duncan and my collecting trips. That's him in the distance over there. Okay, so I've just put some samples here of different types of algae that you find. You see all the rocks in the foreground and the background are covered with some sort of algae. So we get into that a little bit more. So this is just an example of the three groups. So the first slide, very easily, of course, we know that marine plants, algae, especially the phytoplankton at the base of the marine oceanic food chain, they're all photosynthetic. They contain chlorophyll. There are more than 600 species in the western tropical Atlantic. Unlike true flowering plants and so, these are more simpler plants, and instead of roots and stems and leaves, we have similar structures, but they're all a little different. So I have a little diagram here just to show you the plant is attached to either rubber or stones or so on the seafloor by a holdfast or rhizoid. They have runners that would sort of spread along the seafloor called rhizome, and they would support the stalk or spike that comes up from the runners, the rhizome, and instead of leaves, they have blades. So that's sort of the general description that I'll be saying when I go through this. The plants are classified, the algae are classified into the different phyla, but we'll only be talking about 3 today because those are the ones that sort of like come to the forefront when you're on the beach. And this would be the rhodophyta, the chlorophyta, and the phaeophyta. And the rhodophyta, while all the plants contain chlorophyll, the rhodophyta have another accessory pigment called phycoerythrin that helps to give them their red color. Phycoerythrin also helps the plant able to absorb another wavelength of sunshine when the plants are exposed. Chlorophyta, as you said, has chlorophyll, and phaeophyta would have something called fucoxanthin. Okay, so that's just, again, some terms that I'm saying so that you'll be able to be on the same page with me. The different ways in which one would identify the algae. You would have, if one can say, okay, it's a red plant, but that's not the only, color is not the only way to identify the plant, because the colors range, it's not red, it goes from light pink to almost white, to lilac, to mauve, to burgundy brown. So the range of colors are huge. So the color is not the only way in which one would identify a plant. There's also cell wall composition. There's also the products of mating photosynthesis that would indicate which phyla it belongs to. Okay, so the first one we dive into is the red algae. As I said, they contain something called phycoerythrin. And as you can see, they're not what I would call red. They're different ranges and tones of red. I just put some representative samples of each of the groups because we can't go through the whole show today. And these, of course, are for Trinidad. Most of the collections were done along the northeast coast because the macroalgae, they like more rocky shores. They would attach this to stones and rubber, coral rubber, that are just below the surface. So you wouldn't find a lot of algae on a sandy shore like Stormy. Okay, so that's why these collections were mostly from the north and from the northeast coast. So Gracilaria is a well-known alga. It's been around in terms of being used for quite some time, especially in the Caribbean, where Gracilaria is used for something called sea moss. You make drinks out of it, you make use in puddings and ice cream. And it has a particular, what we call phycochlorid, a thickening agent that comes out of it. So that's why they like to use it. It's used with food. We also get what we call clinical agar from it as well. The substance we get from this called agar. And that is used in hospitals and so on, microbiology labs, to be able to grow organisms on, you want to do microbiology tests on different types of bacteria and fungi. So Gracilaria, as you can see, it's a sort of, I would call a burgundy brown kind of color. They hold fast. I'll put a piece of rubber here. Put that one on. And the branching, again, it's very simple branching. It's not terribly complex. But the tips are pointed at the end, and we would say that, okay, that one is pretty easy to identify as just a Gracilaria genus. Because within Gracilarias, of course, there are different species. But that is a little more detailed in how to identify the species. How one usually identifies algae, you look at the branching pattern, you look at the blades, whether they're cylindrical, they're oval, they might have a strong midrib going up the center of the blade, the edge of the blade will be toothed. So there are many different criteria that one has to look at when you're getting it down to species. So they will be just genus. Cyanea, again, that is a red that's kind of flattened. I wouldn't call this heavy branched, but again, it's a little similar, almost similar to Gracilaria type branching, but again, the whole phallus is flattened. Acanthophora, we got this specimen from Salivia Reef. And there's quite, every time I go to Australia, there's quite a bit of Acanthophora there. There's two species that we have. And this is a little more conspicuous because of the sort of ribbed kind of look that it has. And it's a very, it's not a, I wouldn't say plastic, but it's a very robust sort of plant. Okay, so that's the reds. I want to show you one in particular, if you go to the next slide, called Hypnea. Hypnea, again, is quite common along the north coast there. But when you see it at first, it looks like a clump of red algae. You can't differentiate too much from it. But when you look at it a little more closely, the algae sort of reveal interesting variations. In this one in particular, there are lots of little hooks and tendrils that show themselves a little bit. And this isn't even here. This isn't even under microscope. This is just up closer to the camera. So, yes, it may look like a clump of something here, but closer examination is always needed in order just to try and bring it to genus. So right now you just say, yes, it's a red algae. What is it? I do. But the little hooks and tendrils are the giveaway that this is a Hypnea of some kind. Okay, and what's interesting is that the Hypnea is a source of carrageenan, and that is, again, just like agar is a thickening agent, carrageenan is a thickening agent. And it's used in the food industry, the cosmetic industry. It has a wide variety of uses because it doesn't have a strong flavor. So whenever you add it to it, just takes on the flavor of what your product you have. Carrageenan is in toothpaste. You want to use toothpaste too as well? You have it in that. So again, you can't have a strong flavor toothpaste because it's easily done directly. Okay. It has high antioxidant properties and it's used in hair and skin products. When I was doing research for the different algae, there's a site that sort of went through what plant is, what it looks like, the uses, and everything seemed to fall into a category of either food, feed, fertilizer, face, pharmaceuticals. This is a wide range, and there are hundreds and thousands of products that come from any of those different uses. Okay, so for this one, of course, it had high antioxidant properties, used in hair and skin products, things like hair color that people would use. And it's an invasive species. Now, it's very easy for plants to become invasive species because they're attached to anything to do with shipping, anchor lines, chains, ropes, and they are easily transported to another country, another ocean. So a lot of the sort of plants that what I would say use all over the world, they have gotten there because it's an invasive species. Okay? And of course, I'm sure you're familiar with invasive species, you know that animals and plants that hitch a ride and get to other places where they weren't from originally, and then they stabilize and they sort of do a lot of damage to the ecology of the new area. Okay, so that's red algae in a basket. And the next group we're going to go on to is the green algae. Again, we want to have chlorophyta. And again, these are 4 representative samples that you would probably find if you go out on the beaches at Trinidad and Tobago. Algae is called sea lettuce. Not all the algae have common names. That's why I use the scientific names, because those are the ones I know, and common names are usually common to the area which they're from. The Togo might call it something, the down of Mayaro might call it something else. So I use the scientific names. Sea lettuce, algae, is a plant that is used sometimes in the Caribbean. It's definitely used out in the Far East, and it's consumed. They eat that. And salad, they eat it fresh, they eat it raw in salads and so. The caulerpa is a, well, sorry, the back to sea lettuce, as you can see, it's very recognizable. It has a sort of a plastic look to it. And when you touch it, it feels very food. It's not at all what we call filamentous. Caulerpa is very well represented in Trinidad. For this book, we went through, and there are at least a dozen different species of caulerpa in Trinidad. At least a dozen. This is just one of them, Caulerpa circulariores, and this is a good example here of, okay, these are the rhizomes that are running, the runners. Okay. These here would be kind of the fronds that are standing up, holding the leaves of the plant. Okay. And this is how it's spread. It's spread along the seafloor. Again, all the rhizomes are attached to some little rock or stone underneath the sand. Okay. So the caulerpas are quite successful. There's one in particular called Caulerpa taxifolia, which we had only in the literature on the east coast of Trinidad. And about 5 years ago, we came upon it in Williams Beach and the west coast of Trinidad. So the story of Caulerpa taxifolia is that it is called a killer weed in the Mediterranean. Okay. It's a very good aquarium decoration plant. And so what was done is that some Caulerpa taxifolia was genetically modified to be able to be used commercially, especially in aquarium, and so long life you had fish in it so that you could clean your aquarium. But what happened is that some of it, this was in aquarium in Monaco, and unfortunately some of it got out into the Mediterranean Sea. And from then on, it just took off. And because it was genetically modified, it stand in fish eating it, and so it spread. So it has a predator effect. And so this Caulerpa taxifolia has taken over much of the seafood in the Mediterranean. And then the predators, unfortunately.
Lori, are you going to introduce the word syncytium into our vocabulary?
Why not? Okay, so Hanamida, so far we've only found it to be. It's a calcified alga, has little discs, as you can see. If you go and what they call Kilwin, which is just beyond the airport, there's lots of it that you could find washed up on shore there. There are different, at least 4 or 5 different types of algae that we've recorded. And what it does is it's a very important alga because it contributes to the creation of sand. It has lovely sand beaches, and when these little discs die and decay, they turn white, and then wave action and so would break it up, and then you get your contribution to the sand on the beach. Enteromorpha, this one we found this. A lot of this is what is in the picture that you saw in the beginning. It has what we call siphons that fish like to eat. So it's a good food source for the fish in the area. next slide, I just want to go into more detail, is another colupa, Colupa racemosa, and right off the bat it looks like this. And especially in the Far East, they harvest it and use it as a condiment, use it to flavor their soups and so. Native to Australia, again, invasive worldwide. They don't like to call it seeds. They call it sea vegetable because weed gives you the foundation and something you want. So they dress it up a little bit and call it a sea vegetable. It has a peppery flavor, mild anesthetic, and it is thought to lower blood pressure, treat rheumatism, and the source of iron and magnesium. So these plants are, they contribute to our health as well as they provide oxygen for the ecosystems in which they are, for the fish and other invertebrates. And we have it right here in Trinidad. It isn't eaten in any large amount here. I guess we have other things to eat with it. Our palates aren't as exotic as these in the forest. Yeah.
Where we found it? Where have we found it?
This one again, Solidity.
Yeah, it's common in Solidity, and when you go there, I advise you to try it. I think it's quite tasty. I was
a nice crunch.
Lots of colupa, and the people were not eating it.
Yeah. Right. Okay, so again, against that sort of a rock kind of area where we run to. Yeah. Okay, so the next group is the brown alga, and they contain fucosanthin, again that accessory pigment that gives it its color. And so these again are some common browns that we found. The dictyota up left there has that sort of little bicycle branching at the end. And we got this specimen at Chagrams. Okay. The Padina, again, we also got at Chagrams as well. And this one, these are quite conspicuous because the type of branching that it has. This one here has these sort of concentric circles on each of the blades, and it is a sort of ruffled kind of look, which you will find. Okay. We have at least 8 different species of Sargassum. At least 8 different species of Sargassum. They are quite easily identified because they have different types of blades, as you can see here. So, and they all have these air bladders that have float. And they go through their natural life cycles, and when they die, they get cast from shore. But it's never a lot to cause any concern. Okay, so we have 2 different varieties here. Alright? The brown that I wanted to show you a little more of is something that we don't have here, but I put it in because we have become a nation of sushi consumers. Trinidad never used to eat sushi even 20 years ago. And now we eat sushi, we have so many sushi out there. So the next slide has a plant. It is a cold water plant called Japanese hemp, Undaria, that is native to Asia. And it is used in many popular sushi dishes. And if you go right at Hyatt, Kaizen, or any of the places, this is something that called wakame that is always on the menu. So we're eating these seaweeds, and we're getting, whether it's KK, and we're getting fertilizers, and we're getting so many different products from it, and here we're different uses. Okay, so it's native to Asia. Again, invasive. Spread to Australia, New Zealand, and beyond. But it is used in many, many products, both and consumed, both raw as well as prepared in sushi and in other salads and soups and so soup is a very popular one. Okay. So that in a nutshell is an introduction to some of the algae that we have in the different groups right here in Trinidad. When one goes out on the beach, there's a guidebook that should have bought it. It's called A Guide to Caribbean Plants that I use when we go out, because it has the pictures and descriptions of what it is that you're looking at and such things and so that you can find out. So Caribbean plants by Lee Lum, I highly recommend it. It's a great book to carry about. So I took the sort of liberty to move this presentation around because I know when I was asked to give a title celebration, we would have to speak about the Sargassum event that's been okay, that's been in the press and so. But I want to introduce the Algae of Trinidad and Tobago first before I get into the Sargassum. Because the Sargassum problem, it's what I call an open-ended story right now. The research is unfolding. It's brand new, and we know what the situation is. We don't know what's causing it. We have an idea now because of the ongoing research of where it came from, but why it's happening, that chapter is yet to be written. Okay, so what you're going to see is just sort of a little introduction to that. So I want to start with a place called Sargassum, because everybody's saying Sargassum comes from the Sargassus. Some of it does. Some of it does. That's what I can say. So the next slide is just a little bit about the Sargassus. See, it's located in the North Atlantic gyre. A gyre is a loose circulation of currents that are caused by the predominant winds, and these are usually influenced by the position of views. So, of course, in the our part, we will in the northern hemisphere, gyre moves in a clockwise direction, and the direction in the southern hemisphere. It was first observed, Sargassum plants were first observed in the 15th century when Columbus Cape was coming across to the New World, and he described the drums and the plants in the sea that he saw. Current scientists now call it golden rainforest because they realize the value that it plays to life in the North Atlantic. So it is roughly 1126 km long, 3218 km wide, and the seafloor below is 3.2 kilometers down. Okay, so it's just floating there in the North Atlantic. The species of Sargassum are not what we have here. It's called Sargassum furtans and natans, and they are holopelagic, meaning that they spend their entire life cycle unattached and free-floating in this gyre. Science has found that it provides critical habitat for a range of invertebrates and vertebrates, as well as a new strong for migratory species, for food, because the plants, they are the ones that are basic food right up there. And other animals come in to eat what's living on the blades, what's living below the blades, and so it's a spawning area. You're going to be seeing some other animals later that are using this as a spawning area. It is the only sea that is not bounded by land, it's bounded by currents. The currents are the Gulf Stream, the Canary Current, and the North Equatorial. And that's the sort of picture of what they sort of driftboard. Because as the currents go around, the gyre plants go around, sort of spin, and you get these sort of bowl-like pictures going on. So the next slide gives you that positioning right there. So you have, as I said, in north and west, bounded by the Gulf Stream, going across the Canary Current on the east, North Equatorial. And this is between 20 degrees north and 35 degrees north. So it's a little, not terribly tropical, a little higher than that. Okay, so we have an idea of where this is. And as I said, it's a host to a huge number of vertebrates and invertebrates. We have the ones that pass through on their migratory patterns. The next slide. And these will be animals. These are sampling of some of them. Loggerhead turtles that can come off the coast of Florida, Carolina, Atlantic bluefin tuna, humpback whales on their migratory path from the polar, temperate, and Arctic areas down to the Caribbean to have their young. Flying fish, and flying fish eggs have been discovered attached to the surface of the Sargassum blades. And so when you have young flying fish in juveniles, you have fish like mahi-mahi, dolphin fish coming in to feed off of the flying fish. So this whole lovely food web is all entangled within this Sargassum. And then they have the European eel. And I didn't realize that there were European eels and American eels that come down from their respective continents, get into that gyre, and they spawn, and the larvas and so grow up, and then they spend a little while in there, and then they go swim back up to the rivers where they came. I just think that's my problem. I'm going to find that out. So this is just a sampling of some of the transient life that don't stay. They're there for a while, and then they move on. And then the next slide shows you some of the resident life. And when I was sort of researching this, I came across a group of pictures that I just thought were just fantastic, and I want to share it with you. Because it showed how really tiny these animals are. Because that's why I put on the top picture has the blades and the bladders. And you can see the size of the blades and the bladders. And anybody who's been to the beach has an idea of what Sargassum is like, as you see it washed up. So just look at the size of the blades and bladders to the size of the next few animals you want to see here. To see this is what the unseen and the unappreciated part of what lives in Sargassum. To the next one. So we have this wonderful little fish, and he spends his entire life. Right, all these animals, they cannot get out of Sargassum, they cannot swim out. So they spend their entire life cycle within this Sargassum. We can go through these quite quickly. Again, these things here are hydroids. Again, they're a source of food for the next animal, because if you go to the next one, the sea slug here eats the hydroids. See, there are no hydroids on the blades where he is. Okay, it feeds off the hydroids. Right? And then this lovely. This is a different shrimp from the one before. He has healing right here. So, but I mean, the photography was just blew your mind. It's hard to get something so tiny from these Sargassum. This is quite a common fish in the Sargassum. This is firefish. Alright, so we stop right there. Again, seahorses. Seahorses are just so difficult to see, but I was able to capture one. So this is what Sargassum holds. This is some of the secrets it holds. So when the invasion of Sargassum, because I'm sure you have read in the papers, over the last, I would say, 2 to 3 years, some articles about Sargassum and the invasion of Sargassum. It started in 2011, and it was around the months of April and May when we started getting reports on the internet on Sargassum invading. It's washing up on East Coast beaches in particular. It's getting into bays, it's getting into estuaries, it's getting into inlets, and it's not moving. It's staying right there. And this is reports of tons of this stuff coming in May, June, July, which is getting loose. So next slide just gives you an idea of the extent of the problem. This is in St. Vincent. Yeah. This is in St. Vincent. And I have a couple of slides in the next one, which just shows you in different countries what was going on. So this is on a scale unprecedented in our lifetime. People have never seen this amount of Sargassum. Sargassum would wash up on shores. Probably it would be from the local Sargassum at the end of its life cycle, washing up. But it was enough to be able to use a shovel and get it off the beach. They have to use a backhoe now to get Sargassum off the beach. And one beach in Antigua that had a high-end hotel, that is a 4-star hotel, they had to close the hotel for a week to remove 10,000 tons, I think this is wet meat, of Sargassum off their beach. Okay, so this is Barbados. This is Guayamare. I was there when this came ashore, and I saw the slick or the line of it coming in. And under 10 minutes, it was on the beach and rolling up in the surf, all of its hair. And just before the beach was clean, and it just started rolling. I couldn't stay for the rest of the time, but it's just the thing which came ashore. And of course, Tobago. This is Little Rocky Bay, which is the far end from where Magdalena is. Magdalena is on one end of Magdalena, or two, but there's no Magdalena property to take picture. So this is down at the other end, and this is Grenada. And the next picture, again, this is sampling of what was going on. Where hotels now, it overwhelmed the staff of the hotels, the sort of service and janitor, sort of who had to, they were doing dishes in the evening and so on. They had to hire crews to get this stuff off the beach because it would start to decay after it's there for a couple of days and it's in the hotel, the smell is overbearing, and then you can't get down to a beach to bathe, and that was sort of like the first sort of reports that we got in. Okay. This particular picture, the report that came into this picture was that there's a ferry in BBI that would, I guess, take folks over to Tortuga, and the ferry, they said it was a fast ferry. Sargassum got sucked up into its intake and the ferry was down, and so people could get transported. So again, this is the kinds of repercussions it had. So it affected tourism. It affected port activities. It affected tourism, the use of the coastal communities. They are not like tourists. They're not there for a week and a half. They have to stay and get the stench and get all the flies, and so they come in with all the material. So the issue was beyond what any island had experienced before. Okay, so there was a group from the University of Southern Mississippi, the Gulf Coast Research Laboratory, who were looking at this problem. And we were fortunate enough in November last year to have a visiting researcher come to the Institute of Marine Affairs, and he gave this presentation. He was on his way to the Gulf and Caribbean Symposium, and he was going to give this presentation. So he was kind enough to give it to us first before he moved on to the symposium. And so this was sort of groundbreaking research that they'd done. It was new, and it's quite intriguing. So he was a physical oceanographer. His name is Dr. Ronald Johnson. And he put forward a hypothesis, because again, this is kind of research, is what they think is happening. From a physical oceanographer point of view, he looked at it through satellite tracking. And it's called and so they looked at it through different satellites. They tracked images from this event in 2011. Then there was a dieback in 2012, it wasn't too bad. 2013 it washed ashore again. 2014 it happened again. And in 2014 it was particularly bad because it not only affected islands in the Great Antilles, the West Antilles, Trinidad and Tobago, went into the Gulf of Mexico. And that's where countries like Colombia, the island just off north of Colombia, and so they also got affected. So it persisted and went into the Gulf of Mexico. And his research, as I said, was very interesting. He pointed out to us that traditionally the Sargasso Sea is a source of Sargassum pollutants, Sargassum pollutants. But their satellite tracking showed that in 2005, a new source, a new accumulation region of Sargassum started to show up in the Gulf of Mexico, 2005. And again, this is like through satellite tracking. At that time, the bloom was in the Gulf of Mexico, and our circulation patterns, along the flow of things, whatever's in the Gulf of Mexico, in that gyre, it makes its way out into the Atlantic. So it sort of joins up to the Sargassum in the Sargasso Sea. So where people thought, oh, the Sargassum in the Gulf of Mexico is coming from the Sargasso Sea. No, circulation doesn't work that way. It leaves the Gulf of Mexico, it originates in the Gulf of Mexico, and it goes out into the Sargasso Sea. Okay? So that was sort of the first thing. What causes bloom? Why is this Sargassum blooming in the Gulf of Mexico? So the researchers there, they looked at possible sources, and one was the outflow of water from the Mississippi River, bringing in plants nutrient and important nutrition. As the Mississippi River flows out, it passes through a number of states that probably with corn and other products, other crops that need nutrient enhancement, and so whatever fertilizer excess will come down into the Mississippi, into the Gulf of Mexico, and causes. So that was the hypothesis that was put forward for the cause of the bloom in the Gulf of Mexico. And then when this next bloom occurred and washed up on shores in the Caribbean, that was a different set of things. At the Institute of Marine Affairs, we have remote sensing capability, and I was speaking to our GIS procedure there, and she was saying, well, is it really possible that Sargassum from Sargassum Sea, which is 20 degrees latitude north, can really reach down to 10 degrees north equatorial and affect us? We said, highly unlikely to reach that far down. And so when Dr. Johnson came to the Army, he put forward, spoke about the Gulf of Mexico accumulation, said Sargassum seas cannot get down to Trinidad and Tobago situation. So they were looking at another source of Sargassum, and the hypothesis is another source of Sargassum accumulation region was off of Brazil, north of the Amazon estuary. So we should the next slide. Okay, so I'm going to be giving you some terms here. So there's a region called the NER, N-E-R-R, North Equatorial Recirculating Region. So these are his terms. I'm not comfortable with them yet. And the NER, it forms at the equator, and it sort of, the suspects in it are the North Equatorial Countercurrent and the North Brazil retroflexion. So that in itself is also like a gyre as well. Here. And the areas in black are where Sargassum made landfall within the Caribbean in 2011. Okay? So this area here is where he figured, this accumulation region is about here, where this Sargassum bloom, new bloom, is occurring. So the Amazon River outfalls, and the Sargassum here, so the currents will bring whatever nutrients up to this way. And what he's saying is that this is where they hypothesize that the bloom occurred to cause Sargassum to reach these shores here. Because once it's inside of here, it gets caught in the Guyana current and heads up our way, and then we'll move from that. And of course, there's storms in the area, and you see that will push it further north. Okay? But what was interesting is that at the same time, there was research going on, and there were blooms occurring on the other side of the land, in Sierra Leone and Benin. Benin is the country here. And Sierra Leone and Benin have never, ever in history documented any kind of Sargassum blooms off of their coast with those species. And so when they looked at it, Dr. Johnson and his colleagues, they looked at what they call backtracking of the satellite images for 18 months prior to the 2011 event. And what they found, besides this accumulation region here, is that, and he has a series of satellite images that show a continuous band of Sargassum going across the Atlantic eastward against the current, blooming eastward, and therefore sending Sargassum on the east. Wrap your head around that. It's because currents are flowing this way, right? But the bloom is obviously not being pushed by currents because then it's going in that direction. It's moving on this and it's spreading. So the next picture has, this is what it looked like in Sierra Leone. So these people are completely overwhelmed because they've never seen this amount of Sargassum before. This is a new species to their flora. Incidentally, it's also a new species to our flora as well, our marine flora. We have, as I said, about 8 species of Sargassum, none of them include protons and so it's something new to our marine flora. So of course this brings up a whole lot more questions than it solves, because what they have found out is that this is what happened and this is where we have come from. What caused it is still in speculation, because they think that, all right, let's go to the next slide. We know, we have an idea of what caused the Gulf of Mexico bloom in 2005. So is it some kind of nitrification in enhancement that's occurring, coming down the Amazon, getting caught in that current, heading sort of in the north equatorial current, and the Sargassum is finding optimum condition. Incidentally, that near region is also the area of highest, the warmest temperatures in the North Atlantic. So you have a combination of nutrients with temperatures and just Sargassum accumulating. And then when it is able to make itself into the Caribbean, causing great havoc to countries, as you saw. So, as I said, the research was done by the scientists at GC at the University of Southern Mississippi in 2005. The Gulf of Mexico bloom was hypothesized to be caused by nutrient enhancement in the Mississippi River. Satellite backtracking of the Sargassum of 2011 put it as a source, new source of Brazil, north of the Amazon River estuary. They definitely, this is interesting. The scientists definitely ruled out that Sargassum did not come from the Sargassum Sea. So I guess, so that's good, because our GIS fellow said, no, there's no way circulation can reach that far south and bring so much Sargassum up. It has to come from a bloom that is nearby. And there was the hypothesis right there. So as I said, coastal communities were affected, tourism, fishing, port activities, all negatively affected. And again, after having the 2011, then again in 2014. So, people are getting wary, and scientists are trying to find out why these unprecedented events are now becoming cyclical. So, as I said, it's open-ended research. No, I don't have the answers, but I just thought it was a very interesting hypothesis put forward. It sounds like very plausible, because who knows what is being cleared in the Amazon to do what, that is new fertilizers that are now ending up in the Atlantic and causing bloom.
It's a different species to the Sargassum Sea.
No, it's the same species. This one, Sargassum pollutans and even. That's what makes them so easy to reproduce. They don't have to attach. Their entire life cycle is free floating. They reproduce by fragmentation, which is breaks off another species from it. So it is very conducive to blooming and spreading and the amount that you release. Okay. So the next slide. These are just okay. I just want to show you this website here, seaweedindustry.com. If you're interested, but I can't find it. I want to read everything on it. It has pictures, information, uses, everything about commercially important seeds. Commercially ones, not the ones like the Algae and things like that. The commercial, especially the ones that they use for sushi and things. Okay, because for sushi they have wakame that they use, and they have something called kombus and nori, all these commercially important ones. So it's a very interesting website.